Okay. Welcome everyone to the second half of 9.3. We're going to talk about the half angle formulas and the angle reduction formulas. This is again, reminder on your sheet, they're the same thing. So the good news for this section, the surprise, is that there's nothing new today. Today is actually all old stuff. Remember when I talked about the double angle formula, I said, well, the very first example we did, example 0, sine of 2u, well, that's just sine of u plus u. The double angle formula for sine was really just this, the angle sum formula. Well, likewise, these new sections of formulas that we're talking about today are just this formula over here. Notice how all of these power reducing formulas just have cosine of 2u's. It's because they all just are rearranged version of this identity that we already talked about. We just solved for cosine squared, right? And it makes sense. If we have an identity for a double angle, well then on the other half of that identity, we have a half angle, double, half, depending on which side you look at it, okay? And then these ones, we're gonna talk about both the power reducing and the half angle formula. So again, to solve for sine squared, you just solve for sine squared over right here. So we subtracted 1 divided by -2, and we got the equation for sine squared. Do the same thing with cosine squared for this one right here. For tangent, remember tangent is just sine over cosine. So notice how tangent, the formula for tangent is just the formula for sine divided by the formula for cosine. And when you divide these two quantities, these two fractions, you get a complex fraction and the 2's cancel. So you just get this numerator divided by that numerator is exactly your formula for the power reducing for tangent, okay? So nothing new today, just looks a little different. So again, I'm kind of joking. It is sort of new, but it comes directly from the old stuff. So let's get on to it. We're on example 4. Right. Cosine of the fourth of x as an expression with no powers greater than 1. Now, if you're eventually taking calculus, which I'm pretty sure literally all of you are going to be doing, this problem is the single most important problem probably in the entire section, in the entire chapter even, okay? Because this is huge. Because when we integrate something like cosine to the fourth, we have to do example 4, okay? So this is a technique necessary to solve trigonometric integrals, which will happen in calculus. So very important stuff for the future of your mathematical career. So again, we need to use the power reducing. So right, use power reducing. This is what we need. We need to reduce the power, so using a power reducing formula makes the most sense. So we consult over here. We did examples 1 through 3 yesterday. We consult over here and say we need to reduce the power of cosine, so we're going to use this formula up here. So let's write that down off to the side, right? Cosine squared of u equals 1 plus cosine of 2u divided by 2. This is the power reducing formula, okay? Unfortunately, we don't have cosine squared. We have cosine of the fourth. So we're going to need to do a little bit extra work. Cosine of the fourth of x. Well, notice that that is just cosine squared of x squared. And now we can use the identity, reduce it on the inside. And then we're going to get some other stuff. This is a kind of a nasty example to be starting with, but we're just going straight into the deep end, everyone. So let's use the identity. Cosine squared, the identity for that. And again, it's still being squared. We just plug in the identity for cosine squared of x. So it's going to be 1 plus cosine 2x over 2. And you might say, great, I don't see any more cosine squareds. We're done. But remember, we need to simplify everything that's on the inside. And I've said it once, I'll say it again, and I'll say it 500 more times. One of the hardest things about this whole chapter is the algebra. Be very, very careful when you're simplifying this stuff. It'll really get you. And if you mess up on the algebra, it's really hard to get partial credit because then everything in your future is kind of doomed. So Watch out for algebra, and don't be ashamed to ask questions on the algebra. Just because algebra is something that you have learned before doesn't mean you can't ask questions about it, doesn't mean you can't forget it, doesn't mean that you maybe didn't even learn it in the first place, okay? So just because something was covered in an earlier math class does not mean you can't ask questions about it, all right? It's important, and we'll be using it all the time, so you need to know how to do it. And if you don't, that's okay, but you do need to ask or figure it out. Asking is usually a lot better. Okay, so we have something squared. We could FOIL this out, but I'd like to deal with the fraction first, right? Let's rewrite the inside. You don't have to do this, but you could. 1/2 times 1 plus cosine of 2x. All right, that's all getting squared. So something squared times something else squared. We can actually just pull out. We can factor out the 1/2 squared. And when you square 1/2, it becomes 1/4. And now we're just left with 1 plus cosine of 2x squared, and we can FOIL this out. And so now we don't have to really worry about the fraction. Another way that you could have done this, right? I'm going to go off to the side real quick. If that way leaves you scratching your head, another way you could have organized the algebra here is to think about this as 1 plus cosine of 2x squared divided by the denominator squared. The numerator divided by the numerator squared divided by the denominator squared. This probably would have been a little bit easier of a way to approach it in retrospect. Either way, you're going to get to the same point. All right. So we already dealt with the fraction. Now we need to FOIL out this inside. And remember, right, this right here, this is just something being squared just means it's multiplied by itself. This is 1 plus cosine of 2x times 1 plus cosine of 2x. And then we FOIL, first, outer, inner, last. That's what FOIL stands for. F-O-I-L. So we FOIL that out and we get 1 plus cosine of 2x plus another cosine of 2x. So that's 2 cosines of 2x plus the last term squared, which is cosine squared of 2x. Watch your algebra. And now you hear spooky music. Because now that we've done a little bit of algebra, what was the question asking again? Write it as an expression with no powers greater than 1. This little guy's causing a problem. And you know what that means? We got to do it again. Okay? It was fun the first time. It'll be even more fun the second time. Let's reduce the power of this. All right? Reduce. Okay? Here we go. We're going to do it one more time. For anyone who's not watching this video live, you are really missing out on some interesting chat. So we get 1/4 times 1 plus 2 cosine of 2x plus, we need to use the power reducing formula. We have it right here. 1 plus cosine of 2 times the angle. What is u here? Right? U is 2x. So what's 2u? 4x. U is the angle on the inside, so be careful when you use the second reduction formula. Our angle is different. When you use the reduction formula, the angle doubles. If you have a u with the squared, you're going to have double that angle inside. Here our u is 2x, so watch out for that. So it's going to be, again, 1 plus cosine of double the angle, double of 2x is 4x, divided by 2. Whew! And there's a couple of ways that you could simplify it, but we need to get everything all under the same, we need to collect like terms. Like terms have not been collected. Technically, we've answered the problem. We have written it with no power greater than 1, but we also need to simplify. Anytime you give an answer in math, it should be simplified. So there's a couple of ways of doing this. You could either distribute the 1/4, split up this fraction, and combine like terms on the inside. I'll take either one. So I'm going to leave the 1/4 on the outside. We get 1 plus 2 cosine of 2x plus, if we have addition in the top, that means we can break it up 1 divided by 2 plus cosine of 4x divided by 2, which we can also write like this. All right. And now collect like terms. 1 plus 1/2 is going to be 3/2. So you get 1/4 times 3/2 plus 2 cosine of 2x plus 1/2 cosine of 4x. And I would accept this as a final answer. If you want to be okay, if you want an even better answer though, it doesn't make sense to have a 1/4 out in front. The reason why it made sense to have a 1/4 out in front here is because we factored out all the fractions. We have fractions on the inside anyway. Either factor out another 1/2 or distribute the 1/4. We're going to factor out another 1/2. So we're going to get 1/8 times, this is now going to become 3 plus 4 cosine of 2x. Remember, when you factor out a 1/2, that's like multiplying the inside by 2. So this is a much nicer looking answer. This might get you a nice with a smiley face on your exam, but I'll take either one. All right. So that was the first problem. Welcome to 9.3. We took the whole page for this little guy. That's the power reducing formula. And this is going to be advantageous in the future because you might think integrating this is a heck of a lot easier than integrating this, but you'd be wrong. Okay, this is actually a lot more nicer to work with in a calculus sense. All right, so yeah, there it is. There's a couple of problems like that on the homework. They're good, really good exercises. Because unlike some math, you know that you will use it in the future. Again, even if the only reason you use it in the future is for another math class. You're using it for something. Your education, sure. We'll take it. All right. So example 5. Ooh, example 5 is a good one too. Again, as I mentioned yesterday, I don't always know where these problems are going. I follow my hunches and we explore them together. Example 5 is one of those. Let's verify this. There's no part B, so I'm not going to write a part 8. Verify that sine cubed of 2x is equal to 1/2 sine of 2x times 1 minus cosine of 4x. So remember, every time we want to verify, we want to usually pick the harder side, but not always. Harder side in this case is the right-hand side, and the right-hand side will work, but you have to be very creative. So think about what you're going to do if you start with the right-hand side. You could say, well, this kind of looks like a double angle formula. Or maybe I want to use this kind of looks like the half angle formula, and we could use the double angle formula on that. Maybe it'd work. But we know we could use the power reducing formula on the left. So to me, starting with the left-hand side makes a little bit more sense. You can always, literally always start on either side. What matters is which side can you see things to work with. And if we start with the left-hand side and we get stuck, we'll pause, go back, then go back to the right-hand side. And maybe we can meet in the middle, okay? So there's not ever a wrong choice, just sometimes a more obscured choice. Okay, so let's start with the left-hand side. So left-hand side is sine cubed of 2x. Well, let's look at our identity sheet. Sine cubed. No, there's no sine cubed. But sine cubed is sine times sine squared. And we do have things that we can do with sine squareds. So let's do that. Let's write it in terms of sine squared so we can use the power reducing formula. Why else do we want to use the power reducing formula? Because one of the tricks for verifying things is think about where you're going. We're starting with the left-hand side when we get to the right-hand side. The right-hand side does not have any powers of sine. So we're going to need to reduce those powers of sine. So let's write this as sine. Again, our inside is 2x, don't forget about that, 2x, times sine squared of 2x. Every step, make sure that we're telling the truth. Okay? So sine times sine squared, sine cubed of 2x. Good, we're not liars yet. And then again, off to the side, what do we have? We're going to need to use the power reducing formula, which says that sine squared of any angle, u, is going to be 1 minus cosine, 1 minus cosine of double that angle divided by 2. But what is our u here? Our u is 2x. So what is our 2u? Well, you just double it, 4x. So again, if you don't have just an x in here, make sure that when you use the power reducing formula, you're not caught unawares. So this guy, we're just going to keep that there, sine of 2x. Now we want to reduce this thing. So it's going to be 1 minus cosine of double that angle. We said that was 4x. Double that angle is 4x over 2. And ooh, this is looking good. Oh my goodness. This problem was too easy. We should have had a harder problem. Because look, 1 minus cosine of 4x, that's that. Sine of 2x, that's that, divided by 2, same as multiplied by a half. Let's bring the 1/2 out in front just so it's a little more obvious. Right, if we factor out a 1/2 from that little guy, that's all it was. Check. So, again, sometimes these look awful, but just start working with them. Start in a direction. If you get stuck, start from the other direction. Meet your way in the middle. All right. And that's the power reduction formula. This is going to be the single most important thing in calculus, probably. Well, maybe a bit of an exaggeration. One of the most important things that you're going to use in calculus when you get there. Okay, any questions so far? Otherwise, we're going to go into the half angle formulas. All right, so the half angle formulas are kind of funny. Because again, it's just the same thing. In fact, if you look at your identity sheet, the identity sheet, I just have them both in the same place. It's the same formula. Okay? So, right, u is half of 2u. So instead of just writing u and 2u, you could write 1/2 u and u. Okay? All that matters is that the thing on the left is half of the inside on the right. And then all you need to do is to solve for the sine of that half angle. You just square root both sides. Okay? So, again, if you wanted to write, right, we know sine squared of u equals 1 minus cosine of 2u divided by 2. We could write that differently if you want. And if you want to write this on your sheet that you can use on exams, go ahead and write these down. If you want to explicitly write the half angle formula on your sheet, you can. Okay? So, the thing on the left is half the inside of the right. You could write it that way as well. Right? If you wanted, you could write this sine of 1/2 u equals 1 minus cosine of u divided by 2. These are equivalent statements. Technically, we should use a change of variable. Call this w. Where u is 1/2 w. And if u is 1/2 w, all my pens are running dry. Oh my word. No more math for today. Oh. I shall return shortly. All right, we're going to continue with my grading pen. I won't be needing this anyway since everything's going to be online. So, right, if u is just 1/2 of w, then twice that is just w. So it's just a little substitution. So if we want to solve for the left-hand side, we take the square root of both sides. We're going to get plus or minus the square root, 1 minus cosine of w over 2. And if you want to write this formula on your formula sheet, be my guess. And again, the plus or minus doesn't mean both in this case. It means one or the other. You kind of have to choose depending on context. A lot of times we just ignore it though. If we're in the first quadrant anyway. Okay. Anyway. So we chose 1/2 because the left-hand side is just half of the inside, right? U is just a half of 2u. So we're just kind of rephrasing it. This is half of that. So if we want to write this as our variable, then this still has to be half of it. Okay? But it doesn't matter what we're calling it. Only thing that matters is, hey, whatever is on the inside on the left is half of whatever's on the inside of the right. Okay? So let's see if we can solve something with this. Example 6. It looks so weird to be writing notes in red. It's like we're writing math in blood. This is a big deal. Find sine of 15 degrees using a half angle formula. And you can check your answer with the calculator on this. Okay? So, notice 15 degrees is half of 30 degrees. So we can use the half angle formula. Sine of half of the angle, 15 degrees, is going to be, well, do we use the plus or minus for sine of 15 degrees? Is sine of 15 degrees going to be positive or negative? 15 degrees is in the first quadrant, so sine has to be positive. So in this case, we're going to choose the plus. If it said find the sine of negative 15 degrees, then we'd use the minus. Okay? So here we go. Sine of, so notice, right, note, 15 degrees is just 1/2 of 30 degrees. So we're going to use this. Left-hand side is going to be 15, right-hand side is going to be 30. Let's write that out there though. Okay, more explicitly. So we're going to use our formula that says sine of half an angle is going to be the plus or minus the square root of 1 minus cosine of the angle divided by 2. And again, our half angle is 15 degrees here, and our full angle is 30 degrees for this problem. Okay? You can use the unit circle for this problem if you want to memorize a unit circle that has 15 degrees on it. Increments of 15 degrees, you be my guest. So what we have right then is sine of 15 degrees. We just use this formula. We already said, okay, this is 15 degrees in here. This is going to be double that over here. We said we choose the positive side because sine is positive in the first quadrant. And we get 1 minus cosine of its double, which is 30 degrees, over 2. We already did all the hard work. Now we're back to chapter 7. Right, we're going to need our unit, or our special triangles or the unit circle. Right, if this is 30 degrees, this is 60 degrees, we have 1, 2, root 3. What is the cosine of 30 degrees? Adjacent over hypotenuse, root 3 over 2. So we get the square root of 1 minus root 3 over 2 divided by 2. And we have loads of algebra in store for you guys. Trigonometry is over. This problem is an algebraic gold mine because we have an irrational denominator, which I don't always care about, but sometimes simplifying it'll make things easier. And we have a complex fraction. The square roots do not cancel. The square root of a square root is actually a fourth root, but if there's subtraction on the inside, there's nothing that can simplify it. So I have some good news for you guys. We can kill this bird with 2 stones. We can kill 2 birds with 1 stone, right? If we wanted to eliminate the complex fraction, what would we do? We'd multiply by 2 over 2, still inside the square root. And then in the top, we have to distribute that. When it distributes to the 1 times 2 is 2. When it distributes to the second term, the 2's cancel, and we're just left with the square root of 3. Oh, and we multiply on the bottom, 2 times 2 is 4. Ah! We don't know the square root of the numerator, but we do know the square root of the denominator. So we get the square root of 2 minus the square root of 3 all over the square root of 4, and the square root of 4 is just 2. So if you want to memorize this on your unit circle, you go ahead. But that's the answer. And that's as simplified as it gets. It does not get any simpler than that. Okay. There's no way to cancel these double square roots because of the subtraction sign. Algebra, 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 algebra. It's important. And as long as you're doing math, whether you're doing math, chemistry, physics, biology, math in any other field, statistics, algebra is never going to let you go. It's never going to give you up. All right. So it's important if you have questions or uncertainties about the algebra that you ask questions. That's our final answer in all of its glory. All right, example 7. Given is a little throwback. You guys probably feeling a little lonely right now, a little alone. But this is a throwback to the past. And you'll feel comforted when you see this example, maybe. Given that the tangent of alpha is equal to 8 over 15, and alpha is in the third quadrant, find the following. Part A. What is sine of alpha over 2? Oh, Jason, that's easy. Why are you wasting our time? All we have to do is use the half angle formula. Just like yesterday when we did the double angle formula, if I asked you what is the sine of 2 alpha, we just use the double angle formula. Okay? So here we go. Again, all right, it's not actually that easy. Again, remember to start off with a half angle formula. You have plus or minus in the formula. Do we need the plus or the minus here? Let's worry about that later. Okay. So let's just keep that plus or minus real quick. We'll choose one eventually. The square root of, again, 1 minus cosine of alpha divided by 2. Well, we don't know what cosine of alpha is here, but if we draw a triangle, it's all the way back to chapter 7. Okay? So our angle's in the third quadrant. So draw a triangle in the third quadrant. Tangent of alpha is opposite over adjacent. 8 over 15. What's the hypotenuse? Who knows? We're going to have to use the Pythagorean theorem. Also, we're going to the left. The x-coordinate's negative. We're going down. Y-coordinate's negative. So Pythagorean theorem says negative 15 squared plus negative 8 squared is equal to the hypotenuse squared. This will be 225 plus 64 equals c squared. Add these together, you're going to get 289. Square root, it's always positive. You can get 17 as the hypotenuse. If you're really good with your special triangles, you might have recognized, this is my favorite, the old 8, 15, 17 special triangles. But usually most people only remember 3, 4, 5. Sometimes 5, 12, 13. 8, 15, 17 is less common. Okay. But either way, that's our hypotenuse. So what's the cosine then? Cosine is going to be negative 15 over 17. So you get square root of 1 minus negative 15 over 17 over 2. And now we can just simplify the inside. Okay, so it's going to be a bit of algebra. And again, we still haven't really dealt with whether the fact half of that is going to be positive or negative. But we can reason it out. And there's a couple of different ways of doing this. But one way of figuring out whether the sign's going to be positive or negative is that if you have an angle in the third quadrant, if you have that angle, you're either in the first quadrant or the second quadrant. And notice that sine's positive in both of those. So we're actually going to choose this positive part. So we're going to get the square roots of now 1 plus 15 over 17 over 2. And again, algebra is coming back. It's never going away. Well, it actually does go away eventually, but not in math, not in a math class. All right, we have a complex fraction and we have an irrational denominator. So let's deal with the complex fraction first. Multiply the top and the bottom by the LCD inside the square root. Distribute that 17, distribute it to the top. You get 17 plus, the 17's cancel on the second term, 15. On the bottom is 34. And again, I said I don't usually like to make a big deal about rationalizing the denominator unless it's actually going to make things more simple. So here, you don't need to rationalize the denominator. If you're ever uncertain about whether you need to, normally in my face-to-face class, I would just tell you to ask me. But when you're taking an exam online, you won't be able to ask me. But usually you're not going to. The short answer is when you do need to, is when it's going to make it simpler, which is usually when the bottom is 2 terms. If it's just a single number, it's not. But if your denominator was something like square root of 2 plus the square root of 3, then I would want you to rationalize the denominator, because usually in this case, it'll actually make things a lot simpler looking. Okay. So what do we get? We get the square root of 17 plus 15 is 32 divided by 34. And that actually can be simplified. Ooh, look what's going to happen. The top's divisible by 2 and the bottom's divisible by 2. So we just reduce the inside. We get 16 over 17. This is the gift that keeps on giving. Because what's the square root of 16? It's just 4. Ah, we rationalize the numerator at any rate. And there's the answer. Doesn't look too bad. 4 over the square root of 17. So, it's a good idea for the upcoming problems to use the half angle formula. But remember that once we have sine of that half angle, we can actually find what cosine and tangent are as well. Okay? And specifically, we can find cosine by just drawing a triangle. Draw the triangle for alpha over 2 and just solve for the third side. This is adjacent over hypotenuse. We already have 2 of the sides right here, okay? So if you wanted, when we go on to parts B and C, if you actually, and surprisingly, didn't want to use the half angle formula again, what you could do is just draw the triangle and not use the half angle formula. Okay? That is one option, but yeah, it's up to you. Okay? Anyway, let's move on. Part B. Find what the cosine of alpha over 2 is. I'm just going to show you how easy this is. We are going to fly through this one. Okay? What we could do is, again, draw the triangle like I said. Or we could just use the formula. Plus or minus the square root of, now it's going to be 1 plus, I believe. Let me check the formula sheet. Do not have it all memorized. Yeah, it's plus for cosine. 1 plus cosine of double that angle, which is just alpha, over 2. And again, we already found out what cosine of alpha was. We found that out over here. Cosine of alpha is adjacent over hypotenuse, negative 15 over 17. Okay? So, we have plus or minus. If alpha's in the third quadrant, that means alpha over 2 has to be in the second quadrant. So again, is cosine positive or negative in the second quadrant? It's negative, because it has a negative x coordinate. So we get negative 1 plus, again, cosine of alpha. We said cosine of alpha was negative 15 over 17. All right, so we get negative 15 over 17 divided by 2. And I said we're just going to fly through this one because we've already done this. Look, this is almost the exact same problem as part A. 1 plus cosine alpha over 2 in a square root. 1 minus cosine alpha over 2. Okay? Essentially the same thing. There's just a plus here. All the steps are going to be the same. So let's just fly through it, okay? Negative square root. This becomes 1 minus 15 over 17. What do we need to do? We need to simplify the complex fraction. So we're going to multiply by 17 over 17. Again, this is boring. We already did this. Distribute. 17 minus 15 over 2. Simplify. 17 minus 15 is 2 over 2. Oh my goodness. What do we have here? 2 divided by 2? That's just 1. What a beautiful problem. The answer is just -1. Isn't that just refreshing? Just fill you up with a little joy. So elegant, so beautiful at the end. But again, we're going to take the shortcut for part C. If I ask you to find what tangent of alpha over 2 is, just use this sine over cosine. Okay. We found sine in the first part. I don't remember what we found that to be. 4 divided by the square root of 17. We found cosine just now. We said that was -1. Dividing by -1 is the same as multiplying by -1. Yeah, sparks joy. Yeah, you guys are right. So it's just -4 over root 17. Super quick. And mental check. Alpha over 2 is in the second quadrant here. So tangent should be negative in the second quadrant. Remember, all things are positive in the first. Sine's positive in the second. Tangent's positive in the third. Cosine's positive in the fourth. Okay? So that means sine should be the only thing that's positive in the second quadrant. And that's why cosine and tangent are negative here. Great. Beautiful. Sad news for everyone. We only have one problem left today. Shed a tear. But the silver lining is that it has a part A and a part B. Okay? So here we go. Example 8. And yeah, not everyone even takes trig in high school. I didn't take a trigonometry class in high school, which was very interesting when I took the first, when I taught my first trig class. I was like, I never took this class. It's funny teaching a class that you've never taught, or teaching a class you've never taken before, but whatever. It is what it is. Simplify. But do not evaluate. Okay? So for these ones, these are just little mental exercises. It's like solving a Rubik's Cube. Are you going to solve world hunger by solving a Rubik's Cube? No, but it's a little puzzle. It's kind of fun to think about. All right, so part A. Cosine squared of 15 degrees minus sine squared of 15 degrees. So how can we simplify this? Hopefully, when you see this, the cogs in your mind should start turning. Does this look like anything you've seen before? It should. Specifically, it should look like something in chapter 9. Double angle formula. Cosine of a double angle is the cosine squared of that minus the sine squared of that. Right? So that's what we're going to do here. We're going to use the fact that cosine of 2u equals cosine squared of u minus sine squared of u. Well, in this case, what's our u? What is u? What are you? Who are you? Why are you here? I'm so weird. U is 15 degrees. So what's 2u? 30 degrees. Yeah, exactly, Bob. So this is just, right? This is just the double angle formula. This is just going to equal cosine of 2u. And again, 2u we said is 30 degrees. And you might say, oh, let's draw a triangle. I know what cosine of 30 degrees is, but no. Do not evaluate. So stop right there. Simmer down. Read the instructions. Please, please, please read the instructions. If you're taking an exam and you don't read the instructions, I'm going to get very sad. And you might want to make me sad, but anyway. You know what? That problem was so easy. We're going to have a bonus problem. A, B, and C. What about this? Sine squared of 123 degrees plus cosine squared of 123 degrees. Bonus problem. Again, look at this. Should strike a memory. Okay. You're right. It is 1. It's the Pythagorean identity. I don't care what angle you have. The sine squared of that angle plus the cosine squared of that angle is 1. So I don't care whether I wrote 123 degrees, 150 degrees, 179 degrees, 5,238 degrees. Doesn't matter. You type all those into your calculator. You'll get 1 every time. Boom. Wow. That's kind of cool, right, though? You wouldn't think it is, but that's the whole point of these formulas. We have this whole sheet of identities, and on this whole sheet of identities, we have u's, we have variables everywhere. We got v's, we got plus or minuses, we got this, we got that. What does it all mean, though? That's the genius of it. It doesn't matter what angle you have. If you have the sine squared of that angle plus the cosine squared of that angle, it will always equal 1, which is a pretty neat little fact. And if you type in these ones individually, you'll get the same thing, which is pretty cool. Anyway, part C, the final one of the day. This one's a nasty one. But just like most of the nasty stuff in this class, it's only nasty for a brief instant. And then you do 1 or 2 steps and it's gone. 8 sine of 4x times cosine of 4x. And of course, that's one of the tricky things about this class, is that it looks awful and you don't know what to do. But if you can find the right thing, it becomes so much clearer. But if you don't find the right thing, you're just staring at a blank piece of paper, which is the difficulty, okay? So this should strike bells. So what do we do for parts A and B? Both of these, we're simplifying using identities. So we need some kind of identity here. What identity looks anything like that? We have a number. The number probably doesn't matter. We could factor out the number times the sine of an angle times the cosine of that angle. Do we have anything here where it's a sine of an angle times a cosine of an angle? No sine times cosine, no sine times cosine. We sine divided, that's not it. No sine times cosine, no sine times cosine. All right, we have a sine times cosine here, but we're missing another term. Oh. There it is. So let's write that out. Off to the side. This is what we're going to use. We're going to use the fact that sine of 2u equals 2 sine of u cosine of u. Now this doesn't much look like each other, right? So let's make it look like each other. On the right hand side, we don't have a 2, we have an 8. Well, how do we get to an 8? Couldn't we just multiply both sides of this equation by 4? If this is an identity, we could add 1 to both sides. We could subtract pi from both sides. We could do anything to both sides of the equation we want. So let's make it look more like this. If we multiply both sides by 4, we're making a new identity. 4 sine of 2u is going to be 8 now. Sine of u, cosine of u. Good, it looks closer now. But again, oh crap. We're stuck. I don't know what to do. We have a 4x in here, but we have a u in here. Wait, is that a problem? No. It's not. Just say that u is 4x. It doesn't matter what u is. All that matters is whatever u is. It's the same on both of these. It is the same here. And on the left-hand side, it's double that. So, right, if u is 4x, then what is our left-hand side? It's going to be double that, which is 8x. And watch this. You ready for this? We just said that 8 times the sine of 4x times the cosine of 4x is equal to 4 times the sine of 8x. And now we use an identity to make something look a little nicer. And again, if you are doing a calculus problem, this is much easier to integrate and differentiate. So much of what we're doing in this chapter is going to be a lot more useful, very useful in calculus. If you wanted to differentiate this thing, you'd have to use the product rule and the chain rule. Here you only have to use the chain rule. If you wanted to integrate this, you could use a W substitution. Not to be confused with a W substitution. Anyway, these are all things that you're going to be able to use later in calculus. In the meantime, though, they're just pointless little exercises. Can you use these identities? But know that there is a point somewhere, just kind of not yet. All right, so that's it. If you're sweating a little bit watching this video, get started on the homework as soon as possible. And know that chapter 9 is the hardest part of the entire class. This section specifically is one of the hardest sections in the entire class. So when you're doing the homework problems and you get stuck, don't feel stupid. Reach out to others, reach out to me, figure it out. We'll do it together, okay? I am here to give assistance, okay? So don't feel dumb, don't hole up, make sure to talk about it. This is difficult stuff. Hello, October. My cat believes in you, okay? And if October believes in you, you can do it. All right. Have a good day, and feel free to email me if you have any questions.